Hello, grade nines! Welcome to your lesson on naming and writing formulas for molecular and ionic compounds. We're dealing with a really big lesson here, lots of different parts. Important as you go through this that you pause it, try out examples, and really try to process the information. Look at your notes as well, right? Do all that kind of stuff because it's a big one. This is the base for a lot of what we do in Science 10 and then Chem 20 and Chem 30. So having a good understanding of this is critical. Can't stress that enough. Okay, so getting into, first of all, binary molecular compounds. Let's break down what that term means. So when I'm talking about, come on, mouse, work. There we go. When I'm talking about binary molecular compounds, what I'm saying is binary means two different elements, right? Binary is like two options. So here I have two elements. Molecular means I have only non-metal elements involved that are covalently bonded together. And then compounds, a compound means that I have two or more elements bonded together. So breaking down this term, okay, what we're working on for naming and writing formulas first is binary molecular compounds. So let me start off by actually reviewing what I'm talking about when I say nonmetals. When I say two nonmetal elements, I'm talking about the right-hand side of the staircase line. So we're dealing with these guys right here, right? We're talking about these being involved in a compound together. I did not include the noble gases when I drew that shape because remember the noble gases actually can't form bonds at all. So even though they're nonmetals, they will never be involved in a compound unless it's extremely weird situation. Okay, so let's start off by kind of reviewing what we learned last day in terms of ionic and molecular, and then let's talk about the anatomy of a formula and how it looks because we're going to be doing a lot of formulas and reading a lot of formulas to make names. So I have Fe2N3 and then I have C4O10. So take 1 second and think to yourself, which one of these is ionic and which one of these is molecular? Okay, and then the other thing is how many atoms, and I put slash ions because technically we have ions and ionic compounds, but how many atoms, ions would you find in each compound? All right, so maybe pause, think. Here we go. So Fe2N3, this would actually be ionic, and I know that because iron is a metal, right? I find it on the left-hand side of that staircase line. Here's iron, so because it's to the left, okay, that is going to be a metal, and therefore this is an ionic compound. So how many atoms or ions do I have in each compound? And because it's ionic, hint, it's ion. Notice the ion hidden inside of the word ionic. So I actually have 2 iron ions or atoms, right? And then I have 3 nitrogen ions or atoms. So this subscript number applies to the thing it's right after. So when I have the 3 there, that applies to the N, and the 2 here applies to the iron. So in total, I have actually 5 atoms or ions included in this formula. Now, as we're going to talk about later for ionic compounds, it's actually called like a formula unit because it represents the ratio that we have in the crystal lattice for the ionic compounds, unlike for molecular compounds, where it's actually the formula for a molecule, a distinct packet, particle of that particular compound. All right, going to this, C4O10. This is molecular, and the reason why is that these are both non-metals. By the way, the metal will always be first in ionic, so you just have to check the first element, and that will actually tell you. So this means that this is a molecular compound. So what do I have for atoms in here? Well, I have 4 carbons, right, because the 4 comes after the C, and then I have 10 oxygens. So that means in total I have 14 atoms hanging out in this formula. So that's a little bit of the anatomy of how this actually looks. You might be wondering, what is this in the brackets? This is the state, and we're going to learn how to put states on every single formula that we write. Even if it's not correct, I don't care. We're just writing down states. That's good practice and a good habit to get into. So the S stands for solid, and we do put that in a bracket, and notice it's kind of a subscript, right? It's smaller than the rest. Well, the G stands for gas, and of course the liquid would be L, and I kind of do that as a handwritten L so it doesn't look like a 1. Okay, so moving on. When we do, going back to what we're talking about here, molecular naming, we use prefixes that you will find on the back of your periodic table formula sheet in grade 10. We're going to include a copy of this in case you don't have it with this lesson so you can see it, but you actually have these prefixes on the back of your formula sheet. Now you should start memorizing these. In fact, some grade 10 teachers say no to getting this, which I think is a good idea, because you should start memorizing these prefixes. They're just good things to know. And in fact, you see them all throughout life, right? So when you think about a hexagon, it's got 6 sides. An octopus has 8 tentacles. This actually, this I did not realize for a long time in my life. A triangle has 3 angles. 1, 2, 3. The prefix is in the name. So that's kind of neat. Anyways, enough of that. Let's talk about now how we actually do the naming for this. So what we do is we represent how many we have of each atom in the molecular formula by using these prefixes in the name. If there is only one atom of the first element, we do not write mono. Okay, we don't write mono on the first one if there is only one. We do always write mono if there's only one on the second element. And then the last thing is we add an "-ide" ending for the second element. So I want to do one example right here because I think it's worthwhile to do. And then we'll go to the next page, which is just all examples for us to work through this system. So let's say we had CO gas to show you the mono thing. So I take a look and see, oh, this is carbon, right? But I only have one of them. Notice I don't have a number here, subscript number. So that means I have carbon. And then for O, that's oxygen, I have only one. So I need to use the prefix on the second one if there's only one. So this is carbon monoxide. Carbon monoxide. I'm going to try, let's do another one. I don't know if this is going to end up actually being on the next page as well. So if it is, I apologize for the repeat. But let's go ahead and try N2H6. Nah, let's not do that. Let's do N2O5 liquid. So for this, I would have 2 N's. So I've got di-nitrogen. Okay, so di because I have 2 of the nitrogens. And then I have penta because I have 5 of the oxygens. Oxide. Notice I'm changing the ending from - igen, oxygen, to oxide. Sulfur becomes sulfide. Phosphorus becomes phosphide. Chlorine, chloride. I change the ending to -ide to make it work. Okay. Hey, look, it doesn't appear on this example. That's fantastic. So I've got the prefixes to the right here for your reference, and then also you can have it on the document or formula sheet that you have handy. Let's take a look and try out one of these together. Then I'm going to actually let you try out the rest, pause, and then I'll take them up afterwards. So here I have diphosphorus. And I say di because, again, it's got 2. So I'm just putting that prefix in front of phosphorus. And then I have penta, because of 5, oxide, okay, for the -ide ending. All right, so I'm now going to give you a chance. Pause the video, try out 2 through 5. Then we're going to come back. I'll do them with you, right? You can check your work and see how you're doing. Okay, pause now. And we're back. Let's go ahead and try these out. So this actually, oh, sorry, this is rough. This should have been an I. The font is bad for I's and L's. So if you need to fix your answer for that one, maybe go back and do that now. All right, so this is iodine, penta, chloride. Notice I did not put a mono on iodine because it's the first element and I only have one of them, but I'm not going to say mono for the first element. Then I have 5 of the chlorine, so pentachloride. Notice the ide ending, blah, blah, blah. All right, for N7O4, I have 7 nitrogen, so that's hepta for a prefix. So hepta, nitrogen, tetra, oxide. So hepta, nitrogen, tetra, oxide. For NO, I have nitrogen, monoxide. Kind of interesting to note, I don't put two O's in here because then it would look like monoxide, right? That's not how we say it. We say it monoxide. So you need to think about what vowels you put in terms of, how it would sound with those vowels. Now, I mean, this is not something that we'd ever take marks off of, but just, try to strive for perfection, right? Doing it the proper way. And then finally, this one would be sulfur, octa, chloride. So sulfur, octa, chloride. All right, I have a periodic table here for us to reference kind of, as I went through it, but we didn't end up using it. It's all good. So that's the naming. The naming just, you figure out how many you have of each element, then you put the prefix in front, you put "ide" on the last one, you don't put mono on the first element. For formulas, it's actually really easy. For formulas, you're just doing the opposite. So you look at the prefixes in the name, and that tells you the subscript small number that goes after the element symbol. So you're just using prefixes and doing the reverse. So for the state, you're going to put a state on every single formula, and you can pick either solid, liquid, or gas. For most, I don't care which one you pick, it's all good. You just pick whatever you want. There's a few that you should know, like water. You should know that's a liquid at room temperature. Carbon monoxide, carbon dioxide, you should be familiar with those, right? CO2, it's what you're breathing out of your mouth right now, right? CO2 gas, CO gas for carbon monoxide poisoning. You should know H2O liquid. You should know CH4 gas. Natural gas, we talked about that the other day, right? That's what you actually fart, for example, but that's what powers your furnaces. Huge in medicine hat. That's why we're called the gas city, is for this sucker right here. So you want to make sure you have the correct states on ones like that. But those are the biggies. For the rest, you just pick. Now, if you're like, oh, that stresses me out, I don't know which one to use. The less atoms there are, you're going to learn about this in Chem 20. Typically, that means it would be a gas. As we get kind of some more atoms, you could think liquid, and then even more, you could think solid. If you want a line, maybe over 10 go liquid, and then over 15 go solid, but that's not at all. This is such a loose guide just to make you feel more comfortable. I can think of a million exceptions right now for the rules I just gave you. So don't even call them rules. Anyways, let's try this out and see how it goes. So sulfur dioxide. So I notice I don't have a prefix here, but I do have a prefix here. So this means 2 for dioxide. So I'm going to be doing S for sulfur, and I would look up the symbol, right, on the periodic table if you forget. And remember that for this, I'm only looking at the nonmetals, so there aren't that many you have to look at right now. Makes it really nice and easy. So sulfur and then dioxide, I have O2, right, 2 because of the di. Now I need to put a state on there. This is actually a gas. It's a tiny molecule, but if you put liquid or solid, normally we wouldn't mark you down on that, right? But you're actually going to learn about sulfur dioxide later on, probably a bit in environmental chemistry, when we talk about things like acid rain. So you'll learn that it's a gas. This is actually a problem with, for example, using coal as a power source, as it releases a lot of nitrogen and sulfur oxides. Trinitrogen nonafluoride. So nona, look it up on those prefixes here. There they are. Tri is 3, nona is 9. So I got 3 of these, 9 of those. So I've got N, and then I put a little 3 afterwards, and then F, 9, and I pick a state. I feel like this could be a liquid. Let's make it a liquid. All right. Why don't you try out the next 2? Pause it now, come back, and we're back. So carbon dioxide, actually, that's kind of a bad one because we did it on the last screen, but let's go through it anyways. So carbon, no prefix, so I know there's only one, so C. Then dioxide will be O2, and that is a gas. And you need to know that that one's a gas. Again, it's what you're breathing out of your mouth right now. Disulfur hexabromide. So di means I have 2, so I have S2. And then hexabromide, I've got Br, and then 6. I get to pick a state. Let's make this one a solid just for kicks. We haven't done a solid yet. All right, so now we got a solid on there, and we're all done. We're done. That is the writing formulas from names. You just look at the prefixes, and that tells you how many you have. Okay, so in summary, Molecular compounds, I'm going to go back to this slide, are all about the, oh, I can't, that was supposed to be a P. Prefixes. That's what we care about for molecular compound, is the prefixes. What you're going to see for ionic compounds is that we care about instead the charges. It's all about the charge. Okay, I'm going to stop the video there to put this into two parts, and we will take this up with ionic in just a moment's time.